If I take a look at 3/4, it's a constant. If I take a look at pi, it's a constant. So what this really is, if you come down to it, is that y prime is going to be, and I'm going to put some additional notation in, 4/3 pi times the derivative. Now the variable is r with respect to r of r cubed. Now I don't personally put that in, because I know that 4/3 is a constant, pi is a constant. I'm just differentiating r cubed. So this then becomes 4/3 pi times the derivative of 3r cubed, which is what? 3r squared. The 3's reduce out. I'm left with 4 pi r squared. Now, I choose problems for reasons, and because I know that somewhere along the line you might get screwed up on them. If you notice that the exponent on 2 is 1, the exponent on 3 is 1, this is really the same thing as saying 3/2 times 1 over t squared or I can rewrite this as y is equal to 3/2 t to the negative 2 power. Remember, we're dealing with numerical values when we're using power rule. So I'm going to have to write these things as they are. So now I can just use power rule, y prime, the constant, times negative 2 t to the what? Negative 3. So it's going to be negative 2 minus 1, or y prime is negative 3 t to the negative 3. I almost put it over 2. When I'm dealing with square root, what am I dealing with? What's the exponent? If I have t, the square root of t, what would the exponent be? T to what power? 1/2. So I need to turn it into what it is, so that f of t equals 2t. The square root of t cubed is t to what power? 3/2. Plus 4 over t to the 1/2, right? And what's the square root of 2? I can say 2 to the 1/2, but that doesn't make any sense. Square root of 2 is a constant, is it not? I just leave him alone. So that f of t equals 2t to the 3/2 plus 4t to the negative 1/2 plus the square root of 2. And now we play our game, right? F prime of t equals 2 times 3/2 t to the what? 3/2 minus 1 plus 4 times negative 1/2 t to the negative 1/2 minus 1. And the derivative of square root of 2 is?
0.
The 2's reduce out, so I get 3t to the 3/2 minus 1 is 1/2. If I have 1/2, I'm taking away 1. It's 1/2. Yes.
On the second step, how come you did plus 1 2 instead of minus 1 2? it says, you put plus the square root of 2. The square root, sorry.
Supposed to be minus.
It's minus, isn't it minus?
Oh, yeah, okay. Okay, and then this becomes minus, oh, this is t to the 1/2. Minus 4 times 1/2 is 2t to the minus 1/2 minus 1. What's 1 in halves? 2 over 2. So if I had minus 1/2 minus 2 halves is minus 3 halves. Start thinking in fractions, yes.
Better understanding of what this is used for.
We're going to have tons of applications. Remember what this is. The derivative is the instantaneous rate of change. This is the slope of the tangent line, and if this is in t at any time t. This is the radar gun, the speed. You give me the time that the radar gun was, the trigger was pulled, I can tell you how fast you were going. The derivative is the slope of the tangent line. It's the instantaneous rate of change. So if t stands for time, you give me the time that the trooper pulled the trigger, I can tell you how fast you were going at that time if this function represents your speed.
Sorry, what exactly happens to the square root of 2?
Square root of 2 is a constant, and the derivative of a constant is 0. Yeah. Okay, the trick to this is, because I can't do this guy term by term because there's a multiplication there, is I need to multiply it first. So this becomes y equals x squared times x cubed is x to the 5th minus 6, x squared times x is x cubed, plus 7, x squared times 7 is 7x squared. Now that's easy to differentiate, right? So that y prime is 5x to the 4th minus 6 times 3x squared plus 7 times 2x, which is 5x to the 4th minus 18x squared plus 14x. That's y prime, and that's his derivative. Now, by the way, I personally skip that middle step. I go from here to here. So a lot of these things you can do in your head.